Hello everybody, here's Aha's channel. We know based on the Vieta theory, the product of two roots equals c over a, and the sum of two roots is equal to minus b over a for the expression ax squared plus bx plus c equals 0. So if the both conditions are true for x1 and x2, where x1 times x2 is equal to c over a, and x1 plus x2 equal to minus b over a. It means x1 and x2 are two roots for the expression. So what it means is, say you find two numbers 5 and 1. So you want to form a quadratic. You just do 5 equals 1 times 5 to find the product, and 1 plus 5 equals 6 to find the sum. And then you just do x squared minus 6 plus 5, which should be equal to x minus 1 times x minus 5. And yeah, okay. Not only that, so we can base on the Vieta theory to determine the positive and the negative of two roots. For example, so here's our two cases. First case is where c over a, this product is bigger than 0. So x1 and x2 times x2, if it's either both positive or both negative in this case. So if minus b over a is bigger than 0, it means both positive. And if minus b over a is smaller than 0, it means both negative. There are no cases for minus b over a equal to 0, since if minus b over a equals 0, there will be no real roots. This can be found by trying the delta, where b squared minus 4ac for sure in this case is smaller than 0 if a is not equal to 0. The second case is when c over a is smaller than 0. So in this case, when the product is smaller than 0, x1 and x2, one should be positive and the other one should be negative. And if the sum is bigger or equal to 0, then the positive root for sure is bigger or equal to the absolute value of negative roots. Example, suppose letter A is a real number. Consider quadratic equation in x. X squared minus 2ax plus a squared minus 4 equals 0. For what value of a does the equation have two positive roots, and for what value of a does the equation have one positive root and one negative root? Our first step in this question is to check it is possible to obtain the answer. So we try the delta should be bigger than or equal to 0. So we wrote 2a squared bracket square minus 4 times a squared minus 4 bracket bigger or equal than 0. So second, 4a squared minus 4a squared minus plus 16 is bigger or equal to 0. So this shows the delta is always bigger than 0 no matter what. So since we want to have two positive roots, so c over a, the product has to be bigger than 0. Also, the the minus b over a, the sum should be bigger than 0. So a squared minus 4 bigger than 0, and 2a it should be also bigger than 0. So we write a squared bigger than 4, and 2a, no, a should bigger than 0, a bigger than 0. So we combine these two, and we get a bigger or equal, a should bigger than 2, since minus 2 is smaller than 0. Yeah, so a bigger than 2 is our first part answer. For the second question, for what value a does the equation have one positive root and one negative root? So this is really simple. So c over a in this case should smaller than 0, and a squared minus 4 should smaller than 0. So a squared smaller than 4, and a should smaller than plus minus 2. In this case, we don't need to consider any possibility for minus b over a equals 0, since delta is always bigger than 0. So we will always have two real roots. So our final answer is a smaller than 2 and bigger than minus 2. So here's our final answer for question 2. These properties are extended from the Vieta theorem can be a great tool for the question involves quadratic equation, particularly one that involves strict limitation on a kind of root such as two positive roots, two negative roots, or one negative, one positive. Thank you for supporting my channel. If you like it, please hit the like button and subscribe. Thank you.